Welcome to another episode on Applied Electricity, Practically Solo and because today our outline is just current division rule and voltage division rule. Yeah, I can see most of you are already complaining about we not solving a lot of time. We will devote about 3 or 4 episodes for just question solving. We will solve most of the past questions that we have and a whole lot, you understand? So now you are just boarding the concept. If you have the concept and we start solving the question, you see that you'll be getting it. So just have patience and just flow with us, okay? So today we are talking about current division. So let's start with current division. Current division is when you have a total current and that total current is going to be divided for resistors at least 2 or 3, 4, it can be 5, but at this stage the maximum they will give us will be 3. So for resistors to or in order to use current division, we must make sure that the resistors we are talking about are in parallel. So the rule for this is that resistors must be parallel. If they are not in parallel, you can't do current division. So the rule for current division is the resistors must be parallel. So you see a circuit like this. Let's use a simple example. When you get to your questions or you solve more complex examples. So we have R1, R2. Assuming I1 is the current going here, and I2 is the current going here. And you have I total to be the current from the source. So if I total is the current from the source, what is going to happen is that it is going to be divided. That's why it is current division. So since it is current division, this is going to be shared by these two. So the rule is saying that in order to get I1 will be given by, so if I want I1, and I1 is the current going through R1, I'll pick the opposite resistor, not the one I1 is going through, the opposite resistor, which in this case, it is what? R3. So you pick R2, divide by the sum of the two resistors, which is R1 plus R2, and multiply by the total current, which is times IT. If you want to do for I2 too, the same application. So you pick the opposite resistor, which is now R1 all over R1 plus R2 times IT. Or after getting I1, you can easily get I2 by IT minus I1. Then you are done. So that is how current division is done. So in order not to confuse you with the voltage division, let's first solve this example. So assuming this is 2. And if you have 2 there, so we have 3 ohm, 2 ohm. And they told you 10 ampere current is flowing through a circuit. So IT has been given, but not in all questions that they are going to give you IT. Sometimes you are supposed to find the IT by finding the total resistance. After getting the total resistance, you divide the voltage by the total resistance to get the current. But if you are lucky and they give it to you like this, it is a bonus question. So let's see. To get our I1 and I2, we can use current division. So if I want I1, I told you, you must pick the opposite resistor. The one I1 is not going through. So in this case, it is 2. So you have 2 over the sum of the two resistors. 3 plus 2. Then you multiply by the total current, which in this case is 10 ampere. Then you get 4 amps. After getting that one, you go to the next thing, I2. You can use current division or you can use current entry alone. But since I've not taught you Kirchhoff yet, let's stick with the current division. So I2 is also going to be given by the opposite resistor, which is 3 over 3 plus 2 times 10 ampere. And that on the calculator gives you 6 ampere. And this is our I3. So I1 is 4 ampere and our I2 is what? 10 ampere. So we are done with the current division. But a lot of complicated questions can be set on this. It is very simple. Just understand the concept. Any question that they will give you, whether they are 4, they are 5, you'll still apply the same concept. Okay. So let's go to the voltage division. With the voltage division, we said for current division, the resistance must be parallel. The voltage division is opposite. It's opposite. So that one, the resistance must be in series. So in order to do voltage division, resistance must be in series. So, for example, if you have a voltage VT, and you have resistor 1, resistor 2, R1, and the voltage across it is V1, R2, and the voltage across it is V2. Then, if you have this circuit, you can see that the resistors are in series. If they are in series, what happens in voltage division is that this total voltage, if you find the sum, it should give you 0. That is what Kirchhoff said. So it means the voltage across this and this must give us this. So indirectly, V1 plus V2 should be equal to VT. But this one, if you want V1, V1 will be given by, unlike the current division that you pick opposite resistor, this one will pick the actual resistor. So we are going to pick R1 all over the sum of the two, R1 plus R2 times the total voltage. The same applies to the V2. So if you want V2, it is going to give us R2 over R1 plus R2 times VT. So that is the voltage division. So we are done with the concept. Now let's use this example to understand how to set the figure for you. No one is going to give you something quite simple and give you maybe 50 voltage here, 30, 20 ohms, and you just do something simple. No. They are going to challenge you a little bit. So let's see how they are going to challenge us. They will challenge you with a question like this. So with this question, you have 10 volts. And you have 3 ohms. R. And they told you that the voltage across this R, they are intentionally playing with our minds. They said the voltage. So, like I was saying, I said the voltage division is quite simple. But in order for the teachers to trick us and to let the students, or to prevent all the students from getting 100, they will trick you with such a question. They will give you one resistor, and the other resistor will be unknown. After them giving you unknown resistor, they will give you the voltage for the unknown resistor. So, if you have the voltage, I told you here that if you have 2 resistors, then the voltage across the 2 resistors, the sum of them must give you the voltage supply. So the voltage supply here is 10. So you know that 10 should be equal to 4. And let's assume that this is our V2 plus V2. Can't you get V2? Yes, we can get V2. Let's get V2. V2 will be equal to 10 minus 4. And what is N minus 4? You get 6 volts. So V2 is 6 volts. So it means that the voltage across this is what? 6 volts. This is 4 volts. And this is going to give us was V2. So 6 volts. Do you know the current moving through the circuit? No. But since we know that the voltage going through this is 6 volts and the resistance is 3 ohms, we can use Ohm's law. And from Ohm's law, I R is equal to V. So it means I will be equal to V over R. And in this case, our V is what? 6. And our R is what? 3. And what are we going to get? 2 amps. So it means the current flowing through this circuit is 2. Since we need to 2, it means we need 2. And if it is 2, how do you get R? R from that same law. You can make R the target. R will be equal to V over I. And this time our V is what? Is 4. And our I is the same as this one. So we have 2. So you get 2 ohms. So I have not seen anything, or they already said they should find is 2 ohms. So that brings us to the end of this episode. See you on another time for Kirchhoff theory and Thevenin theory.